Hello, everyone, and welcome to the Intrepid Museum's live virtual programming. Thank you so much for joining us for our program, Biome Away from Home today. So happy that you're tuning in with us. My name is Alicia, and I'm an educator at the Intrepid Sea, Air, and Space Museum in New York City. I'll be your host today, and just as a reminder, the museum's live streams are free, but if you'd like to support us in delivering programs just like these, I encourage you to click on the link that you can find in the comments or in the description. So feel free to use the chat today. Say hello, let us know where you're tuning in from. Let us know if you've ever been to the Intrepid before. And of course, if you have any questions, you can put them there as well. Now, our museum, the Intrepid Sea, Air, and Space Museum, is located in a historic World War II aircraft carrier that also served during the Cold War and the Vietnam War. We have a lot of cool airplanes and helicopters, as well as a submarine. Lots of really exciting things to see at our museum. But often when people come, they wonder, okay, I get why you are a sea museum, and I get why you're an air museum, right? You're an aircraft carrier. That makes a lot of sense. But why are you also a space museum? Well, believe it or not, a long time ago in the 1960s, the Intrepid served as a prime recovery vessel for picking up NASA's space capsules. Way back then, NASA was just getting started and they were launching these space capsules up on rockets. And of course, when they came back down again, they'd land in the ocean. Of course, you can't just leave your capsules and your astronauts inside of them floating around in the middle of the ocean. So they needed to be picked up, and the Intrepid was very important in that process. So we picked up a few of those missions, and that's why we also have a really cool connection to space, and of course, why we like to talk a lot about space too. So today we are going to talk a little bit about planets in space with an eye towards what is needed to support life, and specifically human life. We're going to be using this really cool website called Solar System Scope in order to do it. So let's get started and take this journey together. So everyone, take a look right here. What are we looking at? Anyone know? You can tell me in the chat maybe. What is this beautiful blue marble that we are looking at here? Probably an easy guess, you can say, as you're looking at this. But this, everyone, is our home, right? So this is where we live. This is planet Earth. And this is where we are right now in the universe as well. Now, this is the only place that we have ever actually found life as we know it, and all of outer space so far. So I like to start here in order to talk about just why Earth is so special. Planet Earth is able to keep us alive for a few reasons. Tell me in the chat if you think you know one of those reasons. Maybe list off a few of them. There's a few big ones that I can think of. But again, it's very important, again, here on Earth that we have a few specific things. So can anyone tell me in the chat, what are some basic things that we need in order to survive here on Earth? Any thoughts? One of them I can see definitely very clearly here, covering this entire surface of the Earth, and that is water, right? So liquid water is very important, of course. We need that water to survive. We also need something else, and that is oxygen, right? We need oxygen within the atmosphere. So we need air in order to breathe, specifically here on Earth. Very important. So we need to also to keep that air very close to our planet, keeping it contained so it doesn't just go out into space. So we have this thing surrounding the Earth called the atmosphere. The atmosphere, it's that light blue colored kind of shell around it. So we need water to survive, right? We need oxygen in order to breathe and keep our bodies healthy. We also need comfortable temperatures, right? We don't want to be too far away from the sun so that, we're too cold. But we also need to be pretty close, but not too close that we burn up, but close enough so that we don't freeze. So we want to be in something that we, many people refer to as the Goldilocks zone. So not too hot and not too cold. So if you said any of those things, yep, you would be right. And with all of this in mind, do you think that there's anywhere else within our neighborhood of the solar system that we might be able to live? And if humans can't live there, what sort of life might be there already? Interesting thoughts. So everyone, let's take a look at our solar system. So here we go. We are taking a look at some of these inner rings here of our solar system. There it is, all big and laid out for us. So as we know, the planets go around the sun right here in the center. They rotate in orbit all around that center point. So first of all, what does the sun look like and where did it come from? Well, scientists believe that a long time ago, there was a big cloud of dust that was floating around in outer space. Then something happened. Something collided with it. Like another cloud of dust flew on through, or something happened and it began to combine. So these bigger pieces of dust started to smash into each other and they made bigger and bigger pieces of dust. Kind of like if you were in a snowstorm, you might have all those snowflakes that might crash into one another and make bigger snowflakes, right? So eventually all of that dust kind of settled in the middle of that cloud. And that was the beginning of our star, the sun. And as it got bigger and more things collided with those big dust pieces, it also started to pull more and more things towards it and around it too. So a bit further away from all that dust ball, these smaller clumps of this dust started to form, and those began to be our planets. Now, these collisions generate a lot of energy. So imagine a bunch of little explosions on impact when this is happening. And the clumps closer to the sun, as well as the planets that are further away, well, all of them form pretty quickly. A lot of that gas that resulted from the collisions, though, got whipped away. So those four closest planets to the sun are rocky planets, whereas the gases stayed and were collected near the back of the solar system. So those are our gas planets. And that, my friends, is our solar system. So let's start off again by looking at the sun here. Now, the sun is a pretty massive star. Let me ask you a question. Again, you can put your answer in the chat if you happen to know for me. All right, so what percentage, this is going to be a number between 1 and 100, what percentage of the solar system's mass do you think the sun is? Now, when I say mass, I mean everything. So every planet, everything on each planet, every asteroid, every moon, every rock, every person, every house, everything we own, our clothes, our gadgets, everything here on Earth, all of that stuff is mass. All right. So, what percentage of the entire solar system do you think the sun makes up? All right. So, let me know in the chat. Give me a number again between 1 and 100. Which do you think it would be? What percentage do you think it is of all of the mass? All right, so between 1, which would be only one tiny, tiny amount, and 100, which is the whole thing. Like there's nothing else in the solar system. Well, believe it or not, everyone, the answer is 99.86%. Our massive sun makes up 99.86 of all of the mass, all of the stuff in our solar system. It is that big. It's also really bright, too. So researchers once thought that it was just another insignificant star in our Milky Way galaxy, but it's actually now considered to be brighter than about 85% of all of the other stars in our galaxy. So that's really important to consider if we are going to be looking for other Earth-like planets outside of our solar system. And that's something called an exoplanet. And we're going to get onto that in just a little bit. Now, because of its giant mass here, the sun, it attracts other things towards it and around it. And it has, of course, the planets in our solar system that orbit around it too. So let's take a look at the first planet in our solar system. That planet is, of course, going to be Mercury. So here we are at Mercury. Now, if you have seen any of our other programs, you might have heard of Mercury. Of course, we like to refer to it as our Mercury capsule. The Mercury program of NASA was named after the planet Mercury, actually. But before we get into that, even look at this planet here. What does this look like to you? Does this remind you of anything? Maybe that we might even see from here on Earth? Let me know in the chat. What do you think? Does this planet, Mercury, look like anything else to you? It's this gray color. It's kind of rocky. You know, to me, it kind of reminds me of the moon. But this is Mercury. Now, it is named after the Roman messenger god Mercury. This is the closest planet to the sun because the sun, of course, makes all of this stuff swirl around it too. It's a lot like, well, there's a lot of stuff that crashes into Mercury, we'll say. So it is also the most cratered planet. And you can definitely see all those big dents all over it too. Just like our moon has a lot of craters as well. So everyone, here is another question for you. All right. So the Earth, it takes 365 days to go around the sun, right? So that's 1 year for us. Now, keeping in mind that the sun's mass attracts things the closer they are, how many days do you think it takes Mercury to go around the sun? Pop that number in the chat for me if you know. Give me a number of how many days you think is 1 year on Mercury. All right. Now, again, the speed might have something to do with how it got its name, too, from that Roman messenger god who's kind of like their very quick mailman. All right. So you see him a lot with wings on his hat and on his shoes and on his staff. So he's a pretty quick guy. So I would say probably less than 1 year here on Earth. But what do you think? How many days? Generally, the further you go out, the longer it's going to take a planet to go around the sun because it's going to get a bit slower, right? So Earth takes 365 days. It's going to be less than that. So the answer here is it takes 88 days. 88 days for Mercury to rotate around the sun. And that's about a quarter of the time it takes Earth, which is, well, it's about 3 months in our time. Now, Mercury doesn't have an atmosphere surrounding it, as you can see, and that is because it is very close to the sun, of course. It's all been burnt away. But because of that, it can get up to 800 degrees Fahrenheit on the side that's closest to the sun, and then negative 400 degrees, very, 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 very cold on the side facing away from it. It's a little crazy to think about that, right? And it doesn't have the heat spreading up around it, though, like we have here on Earth because of our atmosphere. So, everyone, do you think we can live on Mercury? Probably not. Probably not. Those temperatures are still pretty extreme for us. And it also doesn't have the other things that we need, like air or water as well. So everyone, let's keep moving on now. We are going to take a look a little bit further out at our next planet in our solar system. Anyone know what that is? What is our next planet in our solar system, everyone? It is, of course, Venus. So let's fly to Venus, everyone. All right, so we're going to take a look at Venus now. So Venus is also known as our sister planet. Where do we go? There it is. Venus is known as our sister planet here. And we say that because it's actually very similar in size. It's also another planet that is named after a female deity. So Venus was the Roman goddess of love, of course. I'll make that a little bigger for you. And interestingly enough, it's the only planet that rotates on its axis the opposite direction as us. So it actually is going the opposite direction that we move on our axis going around for each day as it goes around the sun. Now, unfortunately, we cannot live on Venus for yet another reason. Even though Venus is the closest planet to the sun, Venus is still the hottest planet. And it's for the same reason that our planet gets warmer each year, these greenhouse gases. Now, there's a lot of carbon dioxide and other greenhouse gases that trap the sun's heat inside of Venus's atmosphere going on here. So that's an instance of an atmosphere actually that's going to make it harder for us humans to survive if we were there. And the other issue is that the surface is covered in volcanoes that spew out toxic fumes as well. So while it's really pretty, in fact, it's one of the brightest objects in the night sky next to the moon, it's also not really somewhere that we could live, unfortunately. So, my friends, I'm going to pause here and see if we have any questions. So, any questions at all? Let's see. What do we want to start off with? All right. So, what is the sun made out of? All right. Excellent. Let's see. So the sun, everyone, just to give you an idea, it's mostly made out of helium. And that is the stuff, that they put in birthday party balloons, right, to keep them floating up. So it's about 3/4 helium. And the rest of it is made out of other elements, things like carbon or iron or neon and oxygen. And all of that stuff produces an immense amount of heat. All right. So the sun, of course, is very hot. The surface temperature of the sun is actually over 10,000 degrees Fahrenheit. That is almost 6,000 degrees centigrade. But if you also, keep in mind that it doesn't really have a surface per se. It's just this huge ball of gas. And 99% of all of the power of the sun comes from its smaller core. And it's surrounded by something called a photosphere. So it's kind of like a very thin atmosphere that keeps it all in. So even though, it's got that atmosphere, it is way, way, way too hot for us to live on the sun, of course. All right. So let's see. Any other questions? Why does Venus rotate backwards? Oh, good question. So scientists are actually still trying to figure that out. They think that originally it might have spun the same way as the rest of the planets, but that it flipped on its axis 180 degrees at some point. So basically, it's just kind of upside down now, and it looks like it's going the other direction. But why it flipped, they're not sure of. It could be due to the really strong pressure of Venus's atmosphere, so it's 92 times stronger than what we have here on Earth. And that with the sun's gravitational pull Well, it might have moved it somehow. But again, scientists really don't know. It's one of the amazing things about science is that we're always learning new things. There is another theory, though, that it didn't flip. It actually just slowed down in its spinning to a stop at one point, and then it just started up in the other direction again. So who knows? We're still learning. Great question, though. Great question. So, of course, everyone, now after Venus, we have Earth. We talked a little bit about Earth already. But there is, again, something very, very beautiful about Earth that we can check out. I mentioned this a little bit earlier before. We've got this beautiful blue layer around it called the atmosphere, right? So again, it's very important to us. And you could say, like, if the Earth was an egg, you can think of it kind of like a thin eggshell around it. But there's something else that's even more invisible that we don't even think about. So the inside core of our Earth, which I can actually show you here too. Here we go. The inside core of our Earth is made out of metal, and it's molten hot iron and nickel, and it creates something called a magnetic field around our planet. And that's really important because it helps to protect us from particles shooting out from the sun. And as they come towards our planet, these particles can be very dangerous, and they can even strip away our atmosphere that we need to survive. And then if it gets through, well, that's why they tell you to wear sunscreen, right? It can hit our bodies and it gets into our DNA, it can cause mutations, some serious health problems for all living things too, not just human beings. So that magnetic field causes those particles to bounce off and shoot away in other directions into space. But sometimes they do get through that magnetic sphere and they do interact with our atmosphere. And when that happens, it can cause some really neat things to happen in the sky. So does anyone know what we call it when that happens? Tell me in the chat. When the ionized particle from the sun, when all those particles from the sun interact with our atmosphere, sometimes it can cause some really cool things to happen in the sky and appear around the north and south poles. Anyone know what those are called? Beautiful green and kind of purple lights that are dancing around in the sky. There you go, Mr. Nays. Excellent. It's called the Aurora Borealis, or the Northern and Southern Lights. Very nice. Excellent. So everyone, the Earth, again, is located in a very special spot. Let's take a look at our solar system again. If we turn it on its side here, you'll see Earth is right here, right? So it is about 93 million miles from the sun. And it's within a special zone here that I mentioned where water can exist as a liquid on the surface of a rocky planet. Now, we call this region the habitable zone. Habitable, all right? So like a habitat, you can inhabit it rather, or the Goldilocks zone, because again, it's not too hot, it's not too close to center here, but it's not too cold for human life way out there. So every star actually does have a habitable zone or a Goldilocks zone. But it can be further out, it could be closer in, depending on the brightness of the star itself. So this is our habitable zone, right where Earth is right now. So the Earth is also the first planet from the sun that also has a moon as well. So everyone, we can check out that moon too, but I do have a question for you as we start to go to our moon. Everyone, so my question is, have you ever noticed that when you look up into the night sky and you can see the moon, it always does sort of look like it has the same face, right? It always kind of looks the same. We always see the same craters and things that you're kind of looking at right now here, right? But it does spin around the Earth, right? So why don't we ever see this side of it? Why do we only ever see one side of the moon right here? And some people say it looks like a rabbit, or some people say they see a man on the moon, right? All sorts of things that we've seen in the moon, but why do we never see the other side? Well, everyone, the moon is something called tidally locked. It's tidally locked, and that means that the same side of it is always going to be facing the Earth, this side, the one that we're used to seeing. So while we rotate away from it during the day, it is still facing us on one side. Then when we rotate towards it at night, it's still there. It's still facing us, same side. So it does orbit on its path around us. But remember, it's still going around us. And since we're moving too, it's all happening at the same time. So for that reason, we actually only ever see one side of it. Now, you might have heard that this side is, the far side of the moon, or the dark side of the moon, if we have any music fans out there. And recently, China did land a rover on the far side of the moon back here. So it's exciting. We're finally getting some information about what's going on back there, because otherwise we don't really know. We've only really ever landed kind of in this kind of gray area over here in order to look at it. Now, everyone, the next planet that we have, of course, is Mars. Now, Mars is a planet that's been getting a lot of attention lately in the news, on the TV, in the press, of course, because we landed our Perseverance rover on the surface just a few months ago. Very, very exciting planet in order to look at here. So there's been a lot of talk as to whether Mars has maybe once had life, even maybe a long time ago, and whether humans could live there in the future too. Now, while NASA does have plans to put astronauts on Mars within the next few decades, is it the kind of place that we could actually live long term? Well, let's take a look, shall we? So here's Mars. Of course, the red planet, of course. Mars got its name because it looks like a big, angry red eye in the night sky because it does appear red to us. So they named it after the Roman god of war. Now, does anyone in the chat know why Mars is red? Anyone know? You can put that in the chat for me. Why is Mars's surface this red color? Maybe you could take a guess even. You know, we've been lucky to have a number of pictures of Mars because it is so close to us. And that is also really helpful for Perseverance while landing. So we actually had a pretty good idea looking at it of what the terrain would be like because of that, because we can see it from here. So we knew that the terrain, you know, looking around these surface features, we knew that Mars had things like towering volcanoes and canyons and things like that. We also know it has the highest mountain in the whole solar system. And it's actually larger than Mount Everest, believe it or not, which is a pretty big mountain here on Earth. But everyone, the answer is that the surface of Mars here is red because it is covered in iron oxide. All right, so basically rust. It's the same thing that would happen if you left your bike out in the rain. You know, it starts to get a little brownish and rusty. It's that iron oxide reaction. So when iron gets a little bit of air with it, it's oxidized iron. And so that's why Mars looks red. Now, the reason that I brought up the magnetic field before is because looking at Mars is kind of like looking at a science experiment. So when we look at Mars, we can see what might actually eventually happen to our planet. Mars does not have a magnetic sphere anymore, but there is evidence that it might have actually had one in the past, which means that Mars may also have had a very thick atmosphere. And our past Mars rovers have seen that they even think it might have had oceans, whole oceans of liquid water too, and even weather, you know, at one point as well. So that's why Perseverance is so cool. Its primary mission is to look into this more. So to search for possible signs of past life and explore what they believe was once an ancient river delta and a lake around where they've landed, the Jezero crater. Now, of course, we don't know that there's life on Mars for sure. All of this doesn't mean anything used to live there, of course. It just means that Mars at one point might have had what we needed in order to support life. Now, it does still have an atmosphere, but it is much, much, much thinner than ours. And in fact, it's 95% carbon dioxide. So it doesn't do a really great job shielding its surface from these solar particles or, you know, even keeping liquid water in place there. And also, while the temperatures in the summer get to about 70 degrees Fahrenheit, so it's about 20 degrees Celsius, during the day, at night, it can plummet to 200 degrees below 0 Fahrenheit, or about negative 130 Celsius. So with all that said, it is still really fascinating to us, though, and we certainly want to know more about this place and see if maybe there used to be living things there, too. Who knows? All right, my friends, so next up on our tour of the solar system, of course, after we get past our asteroid belt, is the king of the planets. It is, of course, Jupiter. Now, Jupiter, the king of the planets, here's a question about Jupiter. Can anyone tell me, as we fly to Jupiter here? There he is. All right, so can anyone tell me, of course, Jupiter is very famous for its big red spot. Let's find that big red spot. There it is. All right, so this very big red spot. Can anyone tell me what that big red spot is? Does anyone know what that big red spot on Jupiter is? Tell me in the chat if you do. That's one of the most famous markings of Jupiter, that red spot swirling around on it. Anyone know what that is? Any guesses? Big old red spot on Jupiter moving around. So everyone in the chat, if you said yes, it is a giant storm, you'd be correct. Jupiter has been impacted by comets, all right? But that big red spot is a storm that has been raging on for hundreds of years. And ever since scientists have been observing it, they notice that it's actually starting to go away. It has decreased in size just a bit. It's gotten smaller. So Jupiter, though, is something that we call a gas giant. It is a cold gas giant. It's the largest planet in the solar system. It has a ton of moons. There are 79 moons. So, of course, just like the sun, it's attracting a lot of things around it. We'll talk about some of the moons in just a bit. But something else interesting to note about Jupiter is that it spins faster on its axis than any other planet. Because of that, there are very high winds. So that's why you see those swirling bands of color across the surface of Jupiter there. Those beautiful swirling colors there. Now, Jupiter also does have a huge magnetic field, but there's no surface. The magnetic field is caused by its largely liquid hydrogen mantle, but otherwise it is just predominantly gas, again, a gas giant. So Jupiter is also really, really cold too. Now, it is negative 180 degrees Fahrenheit. It's about negative 120 Celsius. Not to mention that it's pretty violent with all of those storms. So yet again, I don't think we would actually want to live there either. Yeah, not so much with Jupiter. But moving on from Jupiter, we've got this one. Probably the most notable of all of the planets with all of those beautiful rings. Check that out. Look at that. But when we actually look at those rings a little bit closer, you'll notice that those rings are actually kind of thin. They're not super thick. Look at how thin they are. Oop, you can also make them, kind of disappear just by tilting your view. Look at that. Almost completely gone. Very, very thin rings. They're just very, very wide when you are looking at it from this angle. Now, those rings are made up of a bunch of dust and rocks and ice. So just debris orbiting around Saturn. And it's actually kind of a good depiction of what the solar system looked like while it was forming many years ago. You imagine the main part of Saturn, this is the sun, and then everything else kind of going around it. That's sort of what our solar system looks like. Now, did you know that Saturn has even more moons than Jupiter? It's got 82 identified moons so far, but possibly as many as 150 right now. They're still identifying a whole bunch of them. But maybe it doesn't surprise you too much because, again, all this other stuff is swirling around it. So maybe they're also attracting some other moons. But Saturn is also a gas giant. It also doesn't really have a surface, so it is primarily gas. It is very, very, very cold. Again, about 200 degrees below zero. And it takes a long time to orbit around the sun. 29 years, in fact. It takes 29 years to orbit. And the winds on Saturn also move 5 times as fast as those on Jupiter, which I mentioned moved very, very fast. So again, probably can't really live too comfortably on Saturn either. So the next planet, everyone, as we keep moving out, of course, we've hit Jupiter, we've hit Saturn. Anyone know which one's next? Right here, Uranus. So let's explore our next planet of Uranus. Now, as we go there, you can see something that might surprise you as we get a little closer to it. Oh, where'd we go? Come on in there. There we go. As we are looking at it here, you'll notice something that might surprise you. Oh, look at that. It also has a ring around it. Did you know that? Now, all 4 gas giants and ice giant planets actually out there do have rings, believe it or not. They're just different sizes and, again, are more or less able to be seen with our telescopes. Saturn, of course, has big giant rings, but Uranus is a little bit smaller. Now, take a look, though. This looks a little bit different than Saturn in how it's configured, too. All right, so if you take a look at this ring here, you'll notice that it kind of looks like it was knocked on its side compared to Saturn, doesn't it? It's going up and down. Isn't that weird? So Uranus has a 97-degree tilt on its side. Now, we don't actually know for sure why, but scientists think that something big, maybe even planet-sized, hit it and knocked it onto its side like that a long, long time ago. And this is now the only planet that actually rotates on its axis in that way. It's special in that regard. Isn't that neat? So that's actually what's really cool about Uranus is that because of its chemical composition as well, Scientists actually also think that it rains diamonds on it. Isn't that amazing? And even when you go there, well, if you could ever go there, let's say, you might actually find oceans of liquid diamonds. What does that look like? Oceans of liquid diamonds. But everyone, before you pack your bags, I do have to warn you, you have to know it is extremely far away. It is very, very, very cold at about negative 350 degrees Fahrenheit. It's the coldest planet in the solar system, which of course is going to be incredibly bad for us humans. We can't survive on that. And also it's going to take you about 84 years, right? 84 years to orbit the sun for 1 year there as well. So, it's beautiful. You might want to go and see some of those diamonds raining there, but might be a little bit painful for us humans. A lot of frostbite on that one. Now, of course, our last planet is Neptune, right? Neptune, and it is even further away. But let's take a look at it anyway, because we can do that. All right, so we've got Saturn, we've got Jupiter. All right, let's find Neptune. We're going to zoom out a little bit. And where is it? One past Uranus. There it is. It's Neptune. Now, Neptune, everyone, it is, as you can see here, as we zoom on into it, it is a beautiful blue planet. And if you take a look, it's also actually got another storm on it. So let's zoom around here on the side. Here we go. You can actually see right here, it's also got a spot. It's a blue spot. So just like Jupiter has its red spot, Neptune has a blue spot. Now, of course, it was named Neptune after the Roman god of the sea, Neptune, because of its blue color, like the ocean. And it is so far from the sun that once, and since it was discovered, it has actually only made over one orbit around the sun. So everyone, it was discovered in 1846, and it takes 165 years for Neptune to go all the way around the sun. 165 years, that is a slow planet. Now, Neptune was discovered actually in a very interesting way. A long time ago, scientists were observing Uranus next door, the one we just visited, and they realized it wasn't moving quite how they expected it to. And the only explanation for that was that there was something else kind of planet-sized that was messing with its orbit. So they did a lot of math, and they decided, all right, based on our calculations, it seems like there should be a planet right about there. And when they looked through the telescope, sure enough, what did they find? Neptune, right about where they expected it to be. So, believe it or not, that is how it was discovered. So, everyone, want to pause one more time here and see if we have any more questions about any of these main planets that we were talking about before. So, any of these main planets. Is there water on Mars? So, we haven't actually found any liquid water on Mars yet. There has been evidence that there might have been at one point. They found signs of water in rock layers and even deposits of sediment on the surface that have minerals that are found in water. And the surface kind of looks like it might have had, huge floods there billions of years ago that collected in, like I said, these giant canyons and craters in these riverbeds that we're exploring now. And there's also signs of frozen water near the south pole of Mars, too. So that's really why we're so excited to go back with the Perseverance rover. We're more than ready ever, now to look into this and to collect samples and see what's up there with that water situation, because who knows? All right. So any other questions here? All right. So how big are Saturn's rings? All right. So we saw that they are actually pretty thin. They are about a half a mile thick. And it's really just, again, how wide they stretch around Saturn that makes it so magnificent. They stretch on for about 200,000 miles wide. And again, it's just a lot of dust and ice. So they reflect the light of the sun really, really well. And that's what makes them shine so brightly, too. Great question. All right. And why is Neptune blue? So that actually has a lot to do with the methane that is in the atmosphere. It absorbs red light really well. So that's where you get that blue color. Again, if it's absorbing the color, you don't see it. You see instead that blue color. But you might have noticed Uranus actually also has that too. That's why it has that pretty kind of cyan color, that kind of blue-green color to it as well. But again, that is caused by the absorption of the red light by the atmospheric methane. Awesome. All right, my friends. So let's continue on now. Many of you here today may have learned that there are 8 planets in the solar system, right? and that Pluto is not actually a full-fledged planet in our solar system. But believe it or not, when I was a kid, maybe when your grown-ups were a kid, Pluto was still considered one of our main planets. It was the last one out there. So does anyone know? Tell me in the chat if you know. What is Pluto now classified as? Anyone know? Tell me in the chat if you happen to know. What is Pluto classified as? And as you are thinking about that, let's explore Pluto. There is Pluto. Poor Pluto has been demoted. Very, very, very far away. But here we go. Here we are in Pluto. So it is super far away. Like I said, it used to be our last planet in the solar system, and now it is something else. Pluto is now classified as a dwarf planet. Now, why is that? Well, there are 3 criteria to make you a planet, all right? First thing is you have to orbit the sun, all right? You have to go around the sun. You also have to have a round shape, and you also have to clear your orbital path. Now, that means that if you are going around the sun, there cannot be anything else that also is along your path there. All right, if you're going around the sun, there can't be anything else around you close by that doesn't also orbit you. All right, so remember we talked about mass and things that are attracting it. So, for instance, the moon orbits around the Earth, right? So the moon is not a planet. The moon is our moon, and the Earth is our planet. So when it comes to Pluto, while it does have 5 known moons, and they do orbit around Pluto, they actually also kind of orbit around each other equally. So because of that, it doesn't quite clear its orbital path, and so it got demoted to a dwarf planet. If we let it be a full planet, we'd have to make all the other dwarf planets full planets too. So it's a little bit more of a specific classification here. But Pluto is still very interesting. It's very icy, as you can see, all this white on it here. It's very icy. It's also, of course, got that cute little heart-shaped ice cap. We love Pluto. Pluto is so sweet. Poor Pluto. Poor Pluto got demoted. But like Uranus, Pluto is also considered to be lying on its side, believe it or not. It is at a 120-degree tilt, which means that its seasons, 120 degrees, guys, 120 degrees is very extreme. Their seasons are very extreme. In fact, during the solstices, so the longest and shortest day of Pluto's year, a quarter of the planet is in constant light or constant darkness. Can you imagine that? A quarter of the planet. And of course, it is also extremely cold at about negative 375 degrees Fahrenheit. And it takes 248 years for it to go all the way around the sun. 248 years. Very far away. So that's our planets, everyone. And, some of the restrictions that humans might face living on some of these other planets. So maybe that gives you a little bit of a sense of why Earth is so special to us and why we haven't just, picked up and moved to another planet just yet. But why limit our search for habitable planets to just human life? Life on Earth takes on some really wild and varied forms, right? You've got all kinds of things that are alive here on Earth. So might there be a place where we can find some other life, maybe not human life, but some other life out in outer space somewhere else? So we may need to stop looking for life on planets, and maybe we could consider starting to look for life on moons. So in that regard, let's take a look again. We are now going to actually look at some moons here. We're going to specifically look at one of Jupiter's moons. We're going to look at Europa. Maybe you've heard of Europa. It's one of the largest moons of Jupiter, and it may look like a lifeless ice ball here, but you might notice something else really interesting about the surface of Europa. Look at that. Do you see all of those scratches on it? Now, underneath all of those scratches, everyone, those scratches are caused by ice. That is frozen, cracked ice. And underneath all of that, everyone, it's got a secret. All right. Europa has a secret. And that secret is oceans. So they actually think that underneath all of that cracked ice, there could potentially be more water than there even is here on Earth. Hubble Space Telescope actually spotted geysers, something they called cryovolcanoes, when we were looking at Europa. And those geysers aren't like Old Faithful, like we have here on Earth with hot and steamy water. No, those are actually cold volcanoes, believe it or not. Cold volcanoes ejecting water and ice about 125 miles off of the surface of this icy moon from under this icy crust. So it does have an atmosphere and it has water. So, hey, could there be life there? Maybe. Not like life, like us necessarily, but some of the things necessary for life as we know it are there. Again, a lot of people think that life really started in the oceans here on the Earth. So, hey, who's to say maybe there aren't some sort of, microbial life, or I don't know, maybe even some alien fish or something like that swimming around under the icy surface there too. So let's take a look at another moon, everyone. Another one we can look at is one from Saturn, actually. This one's really interesting as well, Enceladus. Now, Saturn does actually have two moons that might have life, but let's look at Enceladus first. This one also has those plumes coming out of its surface at the South Pole. Again, covered in ice, covered in, that white, icy caps here all over. Oh, look at that. There's Saturn in the background. Beautiful. But in fact, in 2005, we sent an orbiter, the Cassini orbiter, and it was able to take a closer look at some of those massive geysers, again, that were shooting out from the sides there of this icy little moon. And even cooler, it flew right through some of those geysers, right through the plumes, and it was able to detect organic molecules. So not life necessarily, but things that the life needs, like carbon. So again, it does have an atmosphere and this icy crust with water underneath it. So Enceladus is another really interesting place for us to look at. Another moon of Saturn that is very exciting for us to be looking at too. Probably the most interesting of all of them. Oop, go back here. So another one of these moons of Saturn that we really would love to explore is this one right here. Now this is Titan. I'd heard of this one too. Titan is Saturn's largest moon, and it's the second largest in the whole solar system. But that's not the only thing that makes it special. Titan has an atmosphere, and it is much thicker than Earth's, and it does have oceans, and it does have terrain. It's got land, so it might have life, right? But for sure, we know it is not like life here on Earth, because all of that land and weather and everything under there, all that liquid, it's made out of methane, which is very, very, very toxic to humans. Methane is. So the Cassini orbiter actually used infrared imaging to look through these clouds, and it spotted a whole world, again, with rivers and lakes and seas of liquid methane, even evidence of weather, like rain. But again, all of it was made out of liquid methane. So, we do know here on Earth, deep down in our oceans, we actually do have vents that pump out methane underwater. And there are organisms that hover around those vents, and they thrive on that methane. They feast on it, actually. They love it. So if life has been able to evolve to eat methane here on Earth, hey, maybe it's evolved to do the same thing out on Titan too. We just don't know. But it is really, really interesting nonetheless. Now, everyone, with the advent of the Hubble Space Telescope, of course, we've been able to look out more closely at our solar system and learn more. But we've also, check this out as we zoom out, we've also, everyone, been able to travel outside of our solar system and to look at places even beyond our Milky Way galaxy. Now, we can't take a picture of our own galaxy because, of course, we are in it. We also haven't traveled anywhere near being able to do that as far out there. But we can take pictures of other galaxies nearby and look at their stars. Check that out. And, we can also see things called exoplanets or extrasolar planets. Now, you might wonder, well, we see this, right? That's our Milky Way galaxy. Haven't we taken that picture? No, actually, we haven't. This is just an artistic rendering of what we think it looks like. We've actually never taken a picture of our own galaxy, believe it or not. But these planets that orbit other stars, right? These are exoplanets, exosolar planets, we can say. So not the sun, but another star that is maybe like the sun. Now, there is one that we know of, for instance, called Fomalhaut b, that we have been able to take a very basic picture of. It is very, very, very far away. And there is another system that we know about called the TRAPPIST system, which actually has 4 planets in its Goldilocks zone away from its star. And we also know that they might be ocean worlds too. So that's exciting too. You've got that part ice, part ocean with an atmosphere, so a lot like Earth. And so, hey, who knows? There might actually be life on those planets. We don't know. We are still exploring, but it is a really great place to start. So, as of January of this year, there are 4,341 confirmed exoplanets. Plus, you could say there's also an additional almost 5,000 candidates to be confirmed from a variety of different missions. So we are definitely only scratching the surface of these planets, and there's still so much that's unknown. But with the James Webb Telescope that's eventually going to be going up, possibly at the end of this year, we're hoping we're going to be able to see and get an even better look into the depths of our universe and be able to really start answering some of these questions. And who knows, maybe get one step closer to finding life out there. But of course, with every question we answer, we've got a million more that pop up. So only time will tell. So everyone, that concludes our program for today, Biome Away from Home. But, I will actually pop out a few other things that I saw in the chat earlier. Someone mentioned, have we ever visited an exoplanet? So the answer, sadly, is no. We've never visited an exoplanet. We only have an idea about these distant planets based on what our data from telescopes tell us about their size and their proximity to their star. That's also a really important thing to point out, right? So let's say that we decided to abandon Earth for whatever reason, and we decided to travel to one of those exoplanets that's within a habitable zone. Now, you also have to consider the time that it would even take you to travel there, right? So we think that there might be 2 possibly habitable exoplanets within 10 light years away, still pretty far, that again might, big question here, might be able to support us as humans. Now, 1 light year is the distance it takes light to travel in 1 year. So again, 10 light years, that's the distance it takes light to travel for 10 years. That is, you can equate to about 60 trillion miles away. And that light, therefore, is moving about 700 million miles per hour. Now, our spacecraft can go pretty fast, but not that fast. So Apollo 10 actually set the record for the highest speed of a manned vehicle at close to 25,000 miles per hour. Really, really fast. But again, even at that speed, it's going to still take you something like almost 300,000 years just to go 10 light years away to get to one of those exoplanets. So sadly, even if we wanted to, we wouldn't survive the trip. So we would first need to figure out how to travel at light speed or faster at this point in order to even consider something like that. But who knows? Maybe that could be possible someday. So we'll see. But on that note, everyone, thank you so much for joining us today. I would like to point out that the website that I use today is something called Solar System Scope. So you can check that out, solarsystemscope.com. And you can look at the stars and the planets and the dwarf planets and all the moons, like everything that we just did, and a whole lot more. But everyone, if you have any other questions about our programs, you can feel free to reach out to us through our website, intrepidmuseum.org, or also through our social media. So do be sure to follow or subscribe to this channel and visit our website for any upcoming programs. And also, if you enjoyed this or any of our past programs, we would love your feedback. There is a link in the chat that we encourage you to check out, to click on, please answer a few questions that'll help us to plan our future sessions. So our next family program is Tuesday at 3 p.m. It is High Flying Design, where we're going to talk about the parts of a plane, how they're able to fly, and also taking a few tips from nature in the process. So once again, that's Tuesday at 3 p.m. right here on our streaming platforms. So once again, everyone, I want to thank you so much for joining us today, and hopefully we will see you online for another upcoming Intrepid adventure. Thanks so much, everyone. See you next time.